Okay, this is Pascal's triangle. It's basically made up of 0, choose 0, and then the next line is 1, choose 0, 1, choose 1, and so on. Okay, and this goes on forever. This can be written, if I figure out what all of these are, this comes out to be 1, and that's also 1, and 1. This is 1, that's 2, that's 1, 1, 3, 3, 1. Okay, and you can see what it does here. There's a pattern to this. Okay, so the number that's kind of below and between each two numbers is just the sum of those two numbers. So when you start out with the little triangle here, 1, 1, 1, this becomes 2, these become 3. So the next row would be 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and so on. You can do this forever. Okay, so what are we going to do with this? Okay, what we do with this is we use it with the binomial theorem. That's one of the uses of it anyway. So here I have Pascal's triangle over here. Here I have the binomial theorem. So what is that? So let x and a be any real numbers. For any positive integer n, x plus a to the n power equals n choose 0 times x to the n a to the 0 plus n choose 1 x to the n minus 1 a to the first plus dot 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 plus n choose j x times n minus j times a to the j plus dot 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 n choose n x to the 0 a to the n. Or you can write it as the sum as j goes from 0 to n of n choose j times x to the n minus j times a to the j. Now that sounds super complicated, but once you see the pattern of it with another number, with the actual numbers, it's really pretty easy. So I'll put that up here next. Okay, so here we have x plus 2 to the 5th power, and we want to expand that using the binomial theorem. Okay, so here we go. Very simple. It's going to be 5 choose 0, x to the 5th, 2 to the 0, plus 5 choose 1, x to the 4th, 2 to the 1st, plus 5 choose 2, x to the 3rd, 2 to the 2nd, plus 5 choose 3, x to the 2nd, 2 to the 3rd, plus 5 choose 4, x to the 1st, 2 to the 4th, plus 5 choose 5, x to the 0, 2 to the 5th. Now, where the Pascal's triangle comes in handy is in this next line. I could figure out all these, but that would be a big pain. When all I have to do is I go to Pascal's triangle, and since this is a 5, I'm going to go to the one that has a 5 right here, and I'm going to choose these numbers, and that's going to be equal to these numbers here. So 5 choose 0 is 1 times x to the 5th, 2 to the 0 is 1, plus 5 choose 1 is 5, x to the 4th times 2, plus 5 choose 2 is 10, x to the 3rd times 4, plus 5 choose 3 is also 10, x squared 2 to the 3rd power is 8, 5 choose 4 is 5, x 2 to the 4th is 16, 5 choose 5 is 1, x to the 0 is 1, and, whoops, not plus, times, 2 to the 5th is 32. And now all I have to do is clean this thing up, and I'll have my answer. So this is x to the 5th. That's 10 x to the 4th. This is 40 x to the 3rd plus 80 x squared. 16 times 5 is 80 x plus 32. Now that is certainly a lot easier than taking x plus 2 and multiplying that out 5 times. That is a lot less work. So that's what the binomial theorem is good for.